We're going to investigate the Stirling engine. Listen guys, I had to share this information with you. This Stirling engine is amazing. While we learn about different ways to create energy on CLO Ed TV, you want to gain those informations and then use it and apply it to your own life. Let's look into it. So today we're going to look into two types of Stirling engines. One is the beta formation, and I'll get into that and explain that more later on in the video. And this is the alpha version of the Stirling engine. And what what a Stirling engine simply does, it converts heat energy into mechanical energy. All right, these were widely based off of the steam engines, and this particular Stirling engine was invented in 1816. So let's go over some of the facts dealing with the Stirling engine.
Robert Stirling, born in 1790 in Perthshire, Scotland, died June 6, 1878. He is best known as the inventor for the Stirling engine. He was granted his first patent in 1816 for what became known as the Stirling cycle engine. His company manufactured engines from 1818 to 1922. These engines were used to pump water on farms and to generate electricity. Later attempts to develop the Stirling engine for commercial use proved largely unsuccessful, though its potential for quiet operation, multiple fuel sources, high efficiency, low pollution, and high power density continues to hold considerable attraction for researchers. Stirling engines were powered by an external heat source to force pistons forward and backward within the cylinders that contained them. In modern engines, fuel is ignited, creating a combustion which drives the engine. In the Stirling engine, the gas chamber is actually closed and therefore keeps the gaseous container sealed. This is the fluid that drives the piston forward.
Let me go ahead and move this flame off of the engine. I'll go ahead and take that and turn that off. You can probably hear the engine slowing down, and I'll just give that as some visuals for the other camera. The Stirling engine basically is a way to convert heat energy into mechanical energy. I was really interested in finding out more about this engine because I love learning about ways to create electricity. That's a part of engineering, electrical engineering, that I enjoy learning about. So what we can do in this segment, I'm going to light the flame back up, and we're going to hook up what's known as a voltmeter. What we're going to use this for is actually to check the DC voltage, which means how much direct current this Stirling engine converts heat energy hooked up to a generator, and guess what? That generator is going to produce electricity for us. So let's get the engine back started, and then we're going to get a readout of how much power this guy can produce. Let's get into it. So I'm going to go ahead, light my fuel source, and like I said, you can use a candle, but in this preference, I'm using something that doesn't create soot, keeps it nice and clean burning, and doesn't create a lot of mess, because oils or like a candle you can use, but it's going to create a lot of soot. All right, so I'm going to let the chamber heat up here. This is part of the Stirling engine that's heating up. Once it heats up decently, it will start. Now I'm going to pull this. It may start right away, and it pretty much did. That's amazing. First try. So what I'm going to do is attach, and I'll have a secondary camera over here. I'm going to attach the probes of the voltmeter to these two prongs right here so we can see how much electricity we're generating. All right, voltmeter's on, and go ahead and put this down here. I got to flip the engine around. Bear with me so I can see what we're producing. So one thing you'll notice is while this engine is running, the more revolutions and the more speed it picks up, guess what? The more current it's going to produce. So right now we are producing, according to the camera, looks like 43 milliamps, okay? 43 milliamps. All right. Let's try it again. See if I can hold these steady enough. It's looking like 56, 55, roughly 55 to 65 milliamps. It just jumps up and down. Now, what that simply means is right now, the heat is causing the pistons to move and move that energy around in the closed chamber. And guess what? That spinning motion, we're capturing that energy. When we capture the energy, we got to direct it somewhere. And so that's the purpose of using a small motor to generate electricity. When you add energy to a motor, it will spin. Okay? But if you spin the motor, if it's the right type of motor, guess what? When you spin the motor, it'll make electricity for you. Isn't that interesting? So think about the different ways you can use this application. Could you heat a candle? Could you heat a firewood stove? Is there excess heat generated from an air conditioner compressor or a refrigerator compressor? Imagine utilizing all that waste heat and seeing what you can generate from it. Right now, we're taking that 56 milliamps and connecting it to an LED. And if you look, it is lit. Okay, here I'm going to put that by the voltmeter for the camera so you can see that it is lit. Okay, so perfect application. While I have this LED candle right here, you could use something like this to charge the LED candle to generate light for you. So these are some of the ways to consider it. So we've taken isopropyl alcohol, lit it with a lighter. That lighter is heating the air in the chamber. That chamber is getting moved from the heated air and pushes the piston. That piston moves the hot air to the cool air. The other piston pushes the cool air back to the hot air. And it happens over and over and over again. So that, in essence, is the Stirling engine. Well, I hope you enjoyed this episode of engineering and learning more about the Stirling engine. I've left links in below if you want to research more on the Stirling engine and how it was invented, and some other videos you can look into. If you're interested in picking one up, I'll also leave those links in the description below. Guys, I enjoyed this video and I hope you learned something new. Take care.